My name is Nur Hakimah Hamidi Muhammad Yusof, and my metric number is AF180214.
Jalila binti Juano AF180058.
Name is Munira binti Razwan, AF180093.
My name is Nurwani binti Idrus. My matrix number CF1886.
So I'm going to talk about the introduction of unconfined compression test. So what is unconfined compression test? The unconfined compression test is by far the most method of soil shear testing because it is one of the fastest and cheapest method of measuring shear strength. The method is used primarily for saturated, cohesive soil recovered from thin wall sampling tube. The unconfined compression test is inappropriate for dry, sand or crumbly clay because the material would fall apart without some length of lateral confinement. Okay, in the unconfined compression test, we assume that there is no pore water is lost from the sample during the setup or during the shearing process. A saturated sample will thus remain saturated during the test with no change in the sample volume, water content, void ratio. So most significantly, the sample is held together by effective confining stress that result from negative pore water pressure, which means it is generated by menisci forming between particles on the sample surface. So pore water pressure are not measured in an unconfined compression test. Consequently, the effective stress is unknown. Hence, the undrained shear strength measured in an unconfined test is expressed in terms of the total stress. So, the standard that we use in this test is IS 2720 in part 10, which in the year of 1973. Confined compression strength can be correlated with the consistency of clay that is shown in this table, which is when the consistency is very soft, the QU value will be in 0 to 25, and when soft 25 to 15, medium 50 to 100, stiff 100 to 200, very stiff 200 to 400, and when hard it is more than 400.
For number 1, measure the initial length and diameter of the soil specimen. Number 2, place the specimen on the base plate of the load frame. Number 3, place a hardened steel ball on the bearing plate. Adjust the central line of specimen such that the proven ring and the steel ball are in the same line. Number 4, fix dial gauge to measure vertical compression of the specimen. Number 5, adjust gear position of the load frame to give suitable vertical displacement. Number 6, set the reading of proving ring and dial gauge to 0. Number 7, start applying the load and record the readings of the proving ring dial and strain dial for every 0.2 mm. Number 8, continue loading till failure occurs or 20% vertical deformation is reached. For number 9, sketch the failure pattern. Measure the angle between the cracks and the horizontal if possible.
The result for this test, we can know the specimen 1, specimen 2 and specimen 3 have the same value, which is initial length of specimen, diameter of specimen, initial cross-section area, weight of the specimen, initial volume of specimen. And for the table, we can calculate the bulk density, initial water content, and dry density for all the specimen. For table specimen 1, it shows the compressive stress is increased to 114.8594 and drop until 0. For specimen 2, the compressive stress is begin with 47.21996 and increase to 114.8594, drop back and until 0 and increase to 57.42968. For specimen 3, the compressive stress show the value is 23.60998 and increase to 108.7973 and decrease back and until 0 and increase to 45.94375. The next is the graph of axial stress versus axial strain. For the graph, we can see that the three specimens have the same pattern, which is it is increase, decrease, increase back and drop to 0 and increase back. And the Mohr circle for the specimen is shown. From the stress strain curve and Mohr circle, we can determine the unconfined compressive strength of the soil, which is 152 kilonewton per meter square, and the shear strength of the soil, which is 76 kilonewton per meter square.
In the unconfined compression UC test, from the graph of axial stress against axial strain, the curve for all samples are comprised of linear part and non-linear part. Initially, the curve is sometimes goes up and goes down and straight in the lower and goes up again. So the this obey Hooke law that slope is the Young modulus. So in measuring error, we may get wrong readings from the gauge during the experiment as the pointer is moving. In the presence of air void in the molded sample, air may be trapped inside the sample clay due to improper molding process. This may result in lower unconfined compression stress. So, the improvement need to do unconfined compression test to ensure no air be trapped inside the sample. Clay must be compacted through during molding process, also to ensure no water loss. The experiment should be conducted in a relatively moist environment, or the sample can be covered with a layer of oil to prevent evaporation of water. From the laboratory testing, investigation on unconfined compression strength of soil, the following concluding remarks are drawn. The unconfined compression test is a type of unconsolidated train test that is commonly used for clay specimens. In this test, the confining pressure is 0 and axial load is rapidly applied to specimen to cause failure. At failure, the total load minor principal stress is 0. Test specimen with soil did not show significant improvement in unconfined compressive strain after 7 days in water.